This is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 6-3 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to evaluate logarithms. Now this video is also very important as we continue into logarithms because it shows a couple of kind of rules that we use that are pretty important. So let's start with A here. So it says log base 5 of 125. Now if I wanted to write this as an exponential, I'd say 5 to some power is equal to 125. And I feel like that's a little more obvious, right? So 5 cubed makes 125 because if I do like a factor tree for 125, for example, you can see that I'd have 5 to the third power. Now part B tends to be a little bit more important for us to understand. That was a terrible star, but pretend it's a star, okay? In this case, when I go to write my exponential for this, I have 1/4 to the x is equal to 16. So there's a couple of things to see here. So firstly, I have a fraction being multiplied times itself repeatedly. So what that tells me is that my exponent needs to be a negative. Because otherwise, if I multiply 1/4 times 1/4, I'd get 1/16, not 16. So that negative is going to flip that 4 to the top and that 1 to the bottom. And that'll start getting me whole number solutions. And then what do I have to raise 4 to make it equal 16? That would be the second power. So if ever you see a mix here between a fraction and a whole number, the whole number can be here, like in A, and the fraction can be B here, okay? But if you see a mix between a whole number and a fraction, you know you're probably going to have a negative exponent. So I'm going to jump over to the try it real quick just so that I could show you that this is true in the other case. So if I were to set up an exponential, I'd have 3 to some power equals 1/81. Now, 3 to the 4th would get me 81, but to cause that fraction to flip upside down, that has to be a negative exponent. Okay? So now let's talk about log base 3 of 0. So if I were to write this as an exponential, 3 to some power equals 0. So I have to ask myself, is there any way for me to multiply 3 times itself a bunch of times, or to take 3 and divide it by itself a bunch of times in order to make it equal to 0? Well, 3 times 3 is 9, times 3 is 80, or 27, times 3 is 81, so multiplication didn't work. 3 divided by 3 is 1, divided by 3 is 1/3, divided by 3 is 1/9. So I'm getting like these fractions that have a bigger and bigger denominator, but they're not actually equaling 0. So there is no way that I could raise 3 to an exponent in order to make it 0. This is undefined. That's a really big deal. I would write that down in a note page somewhere. Now this same logic applies here where I have a negative under the logarithm. This is saying I have 7 to some power is equal to -7. Well, there's no way for me to multiply by some exponent, or to multiply 7 by itself to some exponent to make something negative. This is also undefined. So this kind of rule that you need to know is that you cannot have a 0 or a negative underneath a logarithm. So what do you have to remember? You have to remember that it can be positive. You can have a fraction in a logarithm. You can have a root. You can have some kind of power. But you can't have a 0 or a negative. Now another useful little log rule that they don't put here is if you have a log with any base, it doesn't matter what, but inside that logarithm is 1, the rule is that that is equal to 0. Because any number raised to the 0th power is equal to 1. So that's another really useful rule that I would be adding to your kind of list, your formula list. So now for part D, I'm going to write part D as an exponential, but I'm also going to read it aloud, and I think it kind of slaps you in the face when I say it. So what power do you have to raise 2 to make it 2 to the 8th? So if I write this in exponential form, 2 to some power equals 2 to the 8th, and it's kind of really obvious there that x has to equal 8 here. So whenever you have a logarithm and it has a number with an exponent in there, which, I mean, if this said log base 2 of 2 and didn't have an 8 in here, if that was gone, well, this would just be 1, okay? But what ends up happening is the log base 2 and this cancel out, leaving you with just the exponent, okay? So in this case, log base 5 of 5/9, you can just right away call it 9. So there we have it, guys. That's how to evaluate some basic logarithms. Until next time.